everyone, welcome back to my channel. I know I haven't been posting a lot lately because I was busy, and so I apologize for that. But today's video is all about piecewise function. Now, if you already know what a piecewise function is, you can skip ahead and try to do these questions yourself. If not, just stay on. So here, before we get started, let's first explain what piecewise function is. So here, if you look at this equation here and this graph here, you'll notice that, at least for this graph here, you can see that there's 3 different lines. That's not normal. We know that, we know there's linear functions, there's quadratics, there's exponential, there's rational, all those kinds of things. But here, on the right here, what is this? There's like 3 lines. What kind of function is that? And here you can see this equation here. We know that there's equations like, for example, 8x plus 2. That's a linear equation. We know, for example, 8x squared plus x minus 2. That's in standard form quadratic. And there's also like that or that. That's exponential. And so here on the left, you can see this equation here. This doesn't really look normal. And what is this thing here? Don't worry, we'll cover all of that. Now let's just first look at the graph here. As I said earlier, you can see that there are 3 lines here, and they're kind of separate. They're not connected. And so this is what you call a piecewise function. Now, a piecewise function doesn't have to be a combination of all linears. It could also be a combination of quadratics, a combination of exponential, and different kinds of function. But today's video will be simple, and it will be focused on linear piecewise function. And so here you see 3 different lines, right? We have a line here, a line here, and a line here, and they're all linear. But when we're doing piecewise function, it doesn't all have to be linear. It could be something like here, and then it could be a quadratic like that. And if you connect the points, it will look like a quadratic. And so a piecewise function doesn't have to be a combination of its own kind of function. It could be a combination of different kinds of function. And so here you can see that they're not connected. Oh, oops. But when you think of a function, not piecewise function, just any kinds of function in general, a function cannot be something like this. Why? Because if we do the vertical line test, it crosses 2 outputs in the same input. So for all functions, you cannot have more than one output for one input. So it can't be like this, because here it doesn't pass the vertical line test because it crosses at 2 points in the same input. And I apologize for the bad drawing, but let's just say that this is straight, okay? So yeah, a function cannot have any of that. That would be called a relation, but not a function. And so here, this would be a function because remember, when it is, you see that this circle here is colored, this circle here is not colored, and the colored one means that it is inclusive. The one that is not colored is not inclusive. And so here, this whole thing here is a function. We can say that it is a function because it passes the vertical line test. Remember, because this one is not included. And so it passes the vertical line test, so therefore it is a function. Now, we talked about the graph. Now let's talk about what this thing here is. So here we see that this is one line, this is a second line, this is the third line. Now I want you to try ignore this. Let's just focus on these 3 equations here. Now if I tell you to graph this first equation here, you know how to graph it because it's a linear. And if you think about the linear function, it would be, remember, it is y equals to mx plus b, where b is the y-intercept and m is the slope. In this case, x is alone, so we know that the slope is just 1. And here we know that that is the y-intercept. So if I tell you to graph this, let's say this is 1, this is 2, 1, 2, 3. If I tell you to graph this, we know that the y-intercept is at 1. Let me do this so that's clear. We know that the y-intercept is at 1, and we know that the slope is 1. So if I go up 1, it should go up 1. And if you're ever unsure how to graph it, you can always plot points. So let's say if I want to know what the output is when x is equal to 3, I can just substitute x as 3 and then find for y, which is 4. And so it'll be around here, and I can just connect the points here, and you have a straight line here. So that's a way to graph it. And you can see that, oops, let's just erase this without erasing the graph. Okay, good. So if I tell you to graph the second one, we know that it kind of shifts the parent function, which is this x, down 1 unit, because the y-intercept is -1. So it will be something like that. It's not accurate, but it's just an example. And if I tell you to graph 3, same thing. You just move the y-intercept, but the slope is the same. So easy peasy, you know how to graph all 3 of these. Now, let's take a look at here. So for those of you who know what a domain is, you will understand what this is. But if you don't, that's fine. Oh, what's happening? Graph the above. Okay, sorry about that. So let's take a look at here, for example. It says x is greater than or equal to -2, but it is smaller than 0. So what that means is that if let's say this is -1, this is -2, let's just say I have a straight line here. Okay, it goes on forever and then forever. And here it says x has to be greater than -2. So it cannot be less than -2. So I kind of need to chop off this point here and erase everything here. So it says greater than or equal to. So I can just circle in, because remember, as I said earlier, when you color the circle in, that means it is inclusive, and here it is inclusive, so we color it in. And then it says x is less than 0. So I want to erase everything that is greater than 0. So I want to erase everything here up to 0. Now, is it inclusive or not inclusive? It is not inclusive, because here it shows that it is not greater, it's not less than or equal to, it's just less than. So I would circle in without coloring. And so that, if I just say this is x, then that would be how we can graph it. And so now that you kind of know the basic principle for the domain and also how to graph these simple linear functions, we can try graphing them while keeping it inside the domain. So first of all, let's just try graphing x plus 1. So we know that the y-intercept is 1. And let's say here it says x has to be between -2 and 0. So I want to say, okay, what is y when x is -2? And so I plot that in and I get -1. So it's around here. And it says inclusive. Look at the sign here, it's inclusive. So I can color that in and up to all the way up to here. Now, why am I not continuing on? Because it says x has to be less than 0. So I have to stop right at 0. But it cannot be inclusive, because here the sign is not inclusive, so that's why I'm not coloring in. Now let's try moving on to another one. Let's try the second one here, right here. So x minus 1, we know that the y-intercept is -1. But hey, look at the domain. It says this time, instead of having the domain -2 and 0, it is x is greater than 0 and less than 2. Well, look at that. Both of them are not inclusive, so you know that we cannot color it in. And so let's first find out what is y when x is equal to 0. So when x is equal to 0, y is equal to -1. So I know that when x is 0, y is -1, which is right here, not inclusive. And what about 2? 2 minus 1 is 1. So when x is 2, right here, y is 1, so right here. Remember, both are not inclusive. So there you have it, and let's try the last one, which is here. This time we have the y-intercept that is on -3. So let's say this is -3. And then this time it says x is greater than or equal to -2, but less than 4. So I want to find what y is when x is 2. So 2 minus 3 is -1. So when x is equal to 2, y is -1, which is right here. Is it inclusive? Yes, because look at the sign. And it is less than 4, so let's try finding out what y is when x is 4. So 4 minus 1 is +1, which is right here. It's not inclusive because the sign is not less than or equal to. And there you have it. That's our piecewise function. We completed it. It's not perfect, but there you have it. Now, this time, let's try reversing what we did. Instead of graphing it, this time, let's try to find the formula for this. And so, I do apologize for not explaining this, but when you write the formula for piecewise function, you will always have this. I think you call this squirrely bracket. Yeah, you open it with a squirrely bracket, but you don't close it. So make sure not to do that. I'm not sure why we do that, but for now, just do it like that. You can search for other videos, but yeah, I don't know why we don't close it. Sorry. So, write a formula for the above piecewise function. Ooh, that's complicated, but don't worry, they're all linear. So we want to do this step by step. So first, let's try doing this line here. We know that it is linear because it is a straight line. Remember that the formula is y equals to mx plus b. And so here, what is b? Let's try finding b first. Well, we know that b is 7, right? Because this is the y-intercept, and it crosses the y-axis on 7, so b is 7. So let's just first write f of x equals, and we have this thing here. And so I know that the equation here, y equals mx, for this line here, we're working on this line here, plus 7, because we know that y-intercept is 0, 7. Now, how do I find the slope? Here you can see that they're in decimals, and so it's harder, but actually there is a formula. In order to find the slope, we need to do y1 minus y2 over x1 minus x2. What that means is basically, remember, the slope is rise over run. So we know that the rise is in terms of y and the run is in terms of x. So let's say y1 is 6.5. So 6.5 minus 5.5, remember y was y, x was x, over 1 minus 3. And you can use your calculator, but you don't have to, and I get -1 over 2. And so we have the slope. We know that the slope is -1 over 2, and we can write that down. So here, since we already wrote the f of x, we don't have to write the y anymore, so you can just write it as -1 over 2x plus 7. Now, I want to find the domain. Remember, the domain is this thing here. And so to find the domain, here, you can see that we don't have a circle here, and so that just means that it is infinity. So it goes on and on and on and on. And so we can say that x is greater than what? So here, I want to find out what the x is. So you can, when we find the domain, you don't have to care about the y, you just care about the x. So here, this is the endpoint, and I want to know what the x is. Now there's two ways you can find. You can just, here it already says that x is 3, or you can just find, oh okay, if this is 3, then this must be 3. You can do it that way, but since it already oh my gosh, my English. Since it already gave you the x value here, you can just write it as x has to be less than or equal to 3, because here, as I said earlier, it is infinity, and this side here, anything over this side is negative. So I'll say x is less than or equal to -3 because it is inclusive. Now let's try the other one. Oh, this is easy. This is a horizontal straight line, and I don't even need to find the formula in terms of y equals mx plus b, because it's just a straight line, and we can clearly see that it is in between 2, so we can just say y equals to 2. So we have 2 comma, now the domain here, this is 3, but it's not inclusive. X has to be less, sorry, no. Oh yeah, x has to be greater than, not 3, I apologize. It's actually 2. Yeah, no, 3, what am I doing? Yeah, because the x value here is 3. So x has to be greater than 3, but less than or equal to 5, because it is inclusive here. And for the final one, ooh, we have another linear here. What is that? So I want to find the slope first, because I don't know what it doesn't show me the y-intercept, so I want to find the slope first. So remember, it is y1 minus y2 over x1 minus x2. So I usually like to do big minus small, so 7 minus 3 over 5 minus 7, and I get -2. So I know that the m, or the slope, is -2, so y equals to -2x plus b. Now how can we find b? Well, we can plot the x and y value. We can choose either any coordinate you want. Let's just do this one. And we know that y is 7, x is 5. I want to solve for b. So -2 times 5 is 10, -10. And 7 plus 10 is 17. And so we know that b is 17, which means here, sorry, it's a bit messy, y equals to -2x, that's the slope, plus we know that y-intercept is 17. So there you have it. Let's put that down. So 2x plus 17, where, what's the domain? Here I know that the x value is 5, and the x value here is 7, but look, it does not have, it continues on, and it doesn't have the circle here, so that it means it goes on infinity. So we can just say x has to be greater than 5. Not inclusive because it is not colored in. And there you have it. We finished graphing it and also writing a formula for the piecewise function. Thank you so much. I know it was a really long video, and I hope you understood what piecewise function is and how to graph and write the formula for it. Thank you so much for watching.